Today, we're diving into a really fascinating mystery at the heart of AI and language. It's a technical puzzle that has huge implications for the future of AI across the globe. And here's the paradox in a nutshell. The Chinese language, which on paper should be one of the most efficient languages for a computer to process, actually becomes slow and super expensive for today's top AI models. So the big question is, why? All right, to really get this, we first have to talk about why Chinese should be so good for AI in the first place. And it all comes down to a cool concept called information density. Think of information density as how much meaning you can pack into a single symbol. Well, a single Chinese character packs a ton of meaning. It has an information entropy of 9.6 bits. Compare that to an English letter, which is only 4.7 bits. That's more than double the information. It means you can express really complex ideas using way fewer characters. So you'd think, right? Fewer characters should mean less work for the AI, which should make processing faster and cheaper. That's the promise. But in the real world, it's been the complete opposite. Major AI models, especially those built in the West, just struggle with Chinese. They make it less efficient, not more. So what is going on here? What's the culprit? Well, it has a name, and it's called the tokenization trap. This is the main technical reason everything gets turned on its head. Okay, so before an AI can understand any text, it has to chop it up into smaller pieces called tokens. This is literally how an AI learns to read. And how a model does this, how it tokenizes a language, is absolutely critical for how efficient it's going to be. And here's the problem. Most of the big AI models we use today were trained mainly on English. So their reader, their tokenizer, is built for English words. When one of these systems sees a dense, meaningful Chinese character, it has no idea what to do with it. So instead, it just shreds it into 2 or 3 tiny, meaningless digital pieces. All that amazing efficiency is just gone. Imagine taking a beautiful painting and running it through a paper shredder. That's what's happening. And you can see this clear as day in the data. Look at this. For the exact same sentence in Chinese, an English-centric tokenizer like llamas needs 34 tokens. But the Quen tokenizer, which was designed for Chinese, it only needs 16. That's less than half. And you see the same problem with Japanese, which also uses Chinese characters. It's a systemic issue. So what happens when you actually fix this problem? The results are absolutely mind-blowing. By creating a tokenizer that's optimized for Chinese, researchers cut down the time it takes to train and run the AI by 60%. That is not a small improvement. That is a massive, game-changing leap in efficiency. But the story doesn't stop there. Because once you solve the tokenization problem, you run smack into another, completely different challenge: the data scarcity paradox. Now, you're probably thinking, wait a second. China has the biggest internet population in the world. They should be drowning in data, right? And you're right, they are. But there's a huge catch. The issue isn't a lack of raw data, it's a lack of AI-ready data. All the best stuff, books, research papers, it's often locked behind copyright. And trying to manually label data is incredibly expensive. That leaves you with the raw internet, which is mostly noise, just low-quality, repetitive junk. It's like trying to find a needle in a continent-sized haystack. So to get around this, labs have built these incredible data refining pipelines. It's a really clever process. They basically use one powerful AI to read through tons of data and score it on its educational value. Then they use those scores to train a second, specialized AI to be a super smart filter. That filter then sifts through the entire data swamp to pull out just the high-quality gold needed to train new models. Okay, so you fixed the tokenizer and you've refined the data. You should have a super-powered AI, right? Well, this is where things get really, really interesting because the actual performance results are complicated. As you'd expect, models that are native to Chinese are amazing at tasks that need deep cultural knowledge. They get historical references, they understand the subtleties of poetry, they can even work with specialized topics like traditional Chinese medicine. This is stuff a generic model would be totally clueless about. It gives them a powerful cultural moat. But then, a major study found something totally unexpected. When it came to processing really long documents, what's called long context understanding, Chinese ranked 4th from the bottom, out of 26 languages. Now, this makes no sense. A super information-dense language should be fantastic at this. The researchers themselves said the cause was unclear, which just shows how much we still have to learn. And this puzzle is part of a bigger global trend. If you look at this scorecard, you see different models are starting to specialize. GPT-4o is still a great all-arounder. Llama 3 is a beast at English encoding. But look at Kirin, the Chinese native model. It doesn't just ace Chinese tasks, it's also world-class at math reasoning. So it's not about one model being the best anymore. It's about which model is best for a specific job. So let's pull all this together. What does all this complexity tell us about where AI is headed? Well, it points to a pretty fundamental shift in how we should think about AI on a global scale. The big takeaway here is this. The era of a single, English-first, dominant AI model is coming to an end. The future isn't one king of the hill. It's going to be a diverse, decentralized, and truly polyglot ecosystem, where AI speaks every language fluently. And in this future, we're going to see different types of models working together. You'll have the big general models for everyday tasks, but you'll also have powerful regional models that have that native-level understanding of a specific culture. And on top of that, you'll have hyper-specialized models built for deep expertise in fields like medicine or law. Ultimately, this whole shift is about more than just technology. It's about making AI more fair, more accessible, and way more powerful for everyone on the planet. And that leaves us with one final incredible thought. If AI truly learns to think in every single human language, reflecting the full diversity of all our knowledge, what amazing new ideas will it help all of us unlock?